Hey everyone, and welcome. Have you ever had a brand new gadget just mysteriously fail on you? Or maybe you've wondered why the lights in your office sometimes do that weird, annoying flicker. Well, today we're going to pull back the curtain on a hidden electrical problem that might just be the culprit. Let's get into our explainer on the unseen glitch, electrical harmonics. So, what is this invisible force? This thing that's silently stressing out, overheating, and sometimes, ultimately destroying the electronics we depend on every single day. You can think of it like a type of pollution, but it's one you can't see or smell. It's time to uncover the mystery.
Visit youtube.com/avidsystem and don't forget to subscribe.
So first up, let's talk about this unseen electrical glitch. It's really the core reason why perfectly good electronics can just go bad, seemingly without any cause at all. You know that strange humming you might hear from a transformer or a circuit breaker that trips for what feels like no reason? Yep, those are the symptoms. But before we can really dig into what's going wrong, we have to understand what right looks like. So let's meet the star of our electrical grid, the fundamental wave. This is electricity in its absolute purest, most perfect form. See, in a perfect world, our electricity looks just like this. The fundamental frequency is this beautiful, smooth, predictable, and clean sine wave. A great way to think of it is like a pure single musical note, just humming along perfectly at 50 or 60 times per second. This is the ideal power our devices are literally designed to run on. Okay, so if that pure wave is the ideal, what messes it all up? Well, it's time to meet the villain of our story, electrical harmonics. This is the distortion that gets in there and just corrupts everything. To put it simply, harmonics are these extra, totally unwanted frequencies that piggyback on that clean fundamental wave. So if our fundamental is a 60 hertz wave, the second harmonic is double that, 120 hertz. The third is 180 hertz, and on and on. It's like a bunch of noisy, out-of-tune notes playing right over our perfect musical tone, creating this awful dissonance. And here's exactly how that corruption happens. You start with that pure, clean sine wave, but then our modern electronics introduce these extra harmonic waves on top of it. And the result? You get this messy, jagged, distorted wave. This is the corrupted power that's actually reaching our devices. So you've got to ask, where does this distortion even come from? Well, let's start identifying the culprits, and I think you might be a little surprised to find out they are pretty much all around us. Okay, the main source has this kind of technical name, non-linear loads. But don't let the term intimidate you. It's a really simple concept. It just means devices that don't draw power smoothly. So instead of taking these nice, even sips of electricity, they take it in these quick, sharp gulps or pulses. And it's those abrupt pulses that create the distortion. The difference here is crystal clear. Over on the left, you've got your linear loads. Think old-school light bulbs or simple heaters. They draw power nice and smooth. But on the right, you've got the nonlinear loads. And this includes most of our modern electronics, which draw current in those disruptive pulses we were just talking about, completely knocking the waveform out of shape. And who are these nonlinear culprits? Well, just look around you. The power supply in your computer, your phone charger, the motor controller in your air conditioner, even modern LED and fluorescent lights. Basically, almost anything with sophisticated electronics inside is a source of harmonics. Seriously, they're everywhere. All right, so we've established we have this distorted power flowing around. But why does it actually matter? What's the big deal? Let's dive into the damaging effects, because this is where the real tangible problems start to show up. All that distorted energy has to go somewhere, right? And a lot of the time, it just turns into wasted heat. This leads to overheating in wires, in transformers, in motors, which not only wastes a ton of energy, but can be a serious fire hazard. It can also confuse sensitive electronics, causing them to malfunction or trip circuit breakers unexpectedly. It's kind of like trying to run a finely tuned engine on really bad, contaminated fuel. It's just not going to work well. So, how do engineers actually measure this electrical pollution? Well, they use a metric called total harmonic distortion, or THD for short. It's basically just a percentage that tells you how much of the power is made up of those unwanted harmonic frequencies compared to the pure fundamental one. The higher the THD, the dirtier your power is. Simple as that. And just to put that into perspective, here's a number that really matters in the industry. Many standards set the limit for acceptable voltage distortion at just 5%. If you go anywhere above that, you are officially in the danger zone, where problems become way more likely. Now, the good news here is that this isn't some unsolvable mystery. Not at all. Engineers have been working on this problem for a long time, and there are absolutely ways to clean up our power. The main solution is something called a harmonic filter. I want you to think of it like a pair of noise-canceling headphones, but for your electrical system. It's specifically designed to either block or absorb all those unwanted harmonic frequencies, which lets only the pure, fundamental wave pass through. The result is a much cleaner and much more stable power supply for everything. So, look, we have the technology to fix this, but that leaves us with a much bigger question, doesn't it? As our world fills up with more and more of these harmonic-creating devices, who's really responsible for keeping our power clean? Is it the companies making the devices, the owners of the buildings, the big utility companies? It's definitely something to think about. Thanks for tuning in.
Thanks for watching.